Hello everybody. This is a quick demonstration of the proximity sensor project. I have here the baseboard and two proximity sensor boards, one with a printed single coil with 7 turns and a capacitor 270 picofarads in parallel. The other one has two identical coils printed, and each of them has 270 picofarads, again capacitor in parallel. So we have an LC tank here and two identical LC tanks on that one. The baseboard is built around an Atmega 328P microcontroller over here that talks to the key component of the baseboard, which is an inductance to digital converter from Texas Instruments. They talk via SPI, and the inductance to digital converter needs, in this case, a clock signal of 10 megahertz generated by this configurable clock generator that is configured by the microcontroller again. They talk via I2C. The inductance to digital converter drives the LC tank, excites the LC tank, and then reads back the resonant frequency of the LC tank through an 1 to 2 analog switch, a multiplexer basically, that is controlled again by the microcontroller to switch between, especially in the case of the proximity sensor board with two LC tanks, will switch between the two LC tanks. The inductance to digital converter drives, excites the LC tank, and then reads back the resonant frequency, which changes when a metal target approaches the sensor. That change is translated into an indication that the target approached the sensor. The fact that the metal target that I will use approaches the sensor will be indicated with this red LED over here, as well as with some messages printed on this terminal that I have connected to this FTDI programmer over here, which I also use to program the microcontroller. So let me reset the board. You'll see a couple of debug messages and status printed here. You'll see the firmware identified that there is only one LC tank connected. Right. This is the aluminum metal target, which I will be approaching to, perpendicularly to the sensor, and you will see that it will be detected. The red LED detects that, and the messages are printed over here. The firmware is smart enough to detect by scanning what type of a sensor board is connected to it. So I'll connect the other sensor board and I will reset it. You'll see here both LC tanks are connected, are detected. It's very sensitive. I'll move from right to left a little bit. You'll see it's detected and highlighted here with messages from the metal target coming from the right, and the LED on the board coming from the other direction, from the left. Now, if I move slowly, the speed of moving will determine how many messages left and right and the order in which they are printed. So I'll try to move at a constant speed from left to right, and then from right to left. Like that. There you go.